All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. It's me, Lady Ada, with me, Mr. Lady Ada, broadcasting from downtown Manhattan. We're going to check in with people from the maker community. What are they hacking, coding, soldering, tweaking, debugging, and more? Going to also check in with some folks from the Adafruit community,
Right.
our devs and engineers, and the stuff that they're going to be making for you to use.
Yeah, you often get a first look at what we're working on, and also anyone can stop by. We put the links in all the chats. Let's start with Scott. Scott, what you got going on this week?
Hey, I'm really just trying to figure out BLE stuff, but
aren't we all?
Yeah. JP's been really helpful. Yeah, I'm like looking at a log right now from JP for that. But what I thought I'd show and tell is actually some of my soldering handiwork. Lamore, I showed this to you yesterday, but this is an I.MX RT1011, and we had this idea of using a PSRAM chip. So right here, I've soldered a PSRAM chip stacked on top of the flash. Which will give us a setup very similar to an ESP32 where you have an external PSRAM chip. So not only do we have external flash, but we also have external PSRAM, and you wanted me to test it. I went to the makerspace and got it dead bug styled, soldered on top of there.
Okay.
I've been in BLE land for the software stuff, but I'm hoping to be able to confirm that we can use that, and that will give folks a much bigger MicroPython heap for loading code and running it on the I.MX 1011.
All right. Sounds good. I think that'll be awesome. We definitely tried to determine whether that chip even supports it, and we think so.
We think so.
You'll find out.
Yep.
Data sheet's a little vague. Okay.
Yeah, cool. Yeah. I think I know what I need to do. I've been trying to get this BLE stuff done.
Yeah. All right. Well, good luck with that. I think that's also very exciting. People love BLE, and on the S3.
Yeah, it's getting better.
And other expressive chips as well.
Mm-hmm. All right. Well, thanks for stopping by. No deep dive with Scott this week. It is Tim, so tune in this Friday.
Yep, and I haven't asked him yet, but I suspect next week will be as well.
All righty. Okay, well, thanks so much, Scott.
Hi, thanks, Scott.
Thanks.
All right, next up, we're going to go to Maker Melissa. Melissa, what you got going on?
Hi, so I have a Feather ESP32 here, and so this doesn't have a native USB port on it, and so therefore we're not mounting a CircuitPy drive with CircuitPython on it. And in order to get around that, you can currently use web workflow on it, but it's still kind of a pain because you have to go through the REPL and have it generate all the settings toml file. So what I've been working on is something to allow connecting with the USB here. So I'm going to go ahead and connect to it really quick. And then I have been working on making it so you can do all these file operations that work through the REPL here. So like, for instance, if I wanted to upload a little file here to the drive, I can upload it. So I have one here, and I can likewise download it. And any of the other file operations on the board that you can normally do over either web workflow or the Bluetooth workflow.
So it'd be great, really helpful for people who don't want to necessarily set up Wi-Fi workflow, or they want a low power way of connecting to their CircuitPython or even MicroPython boards. This might work with MicroPython as well.
Yeah, I'll have to try MicroPython here soon.
I think it uses almost the same setup where it's like it goes into raw mode, so it probably will work, but we'll find out. Anyways, it looks really good. And I love the user interface. It's so clean and easy.
Thank you.
All righty, thanks so much, Melissa. Next up, we're going to go to Jepler, and then we'll go to Brent and Noe. What's going on, Jeff?
Hi. So last week I showed the METRO ESP32S3, and I was streaming some MP3s. And I said, right now we can only do it from HTTP. So in the time since then, I've been working on adding support for HTTPS. And part of what we need for the MP3 playback is in the background, we want to ask, are there bytes for me to read bytes of MP3 encoded data? And if the socket says yes, then we say, okay, read me up to 1,500 of them. And with non-encrypted sockets, that worked fine. With SSL sockets, I discovered that it doesn't quite work that way. And this is an understanding of somebody who doesn't really know a lot about TLS, so it could all be inaccurate. But here's kind of what I understood. What I would see when I dumped packets read and received on the regular socket, I'd see that it would read like up to 16 kilobytes. And if you go reading the documentation of the TLS protocol, you find where it says it has its own like format of blocks or packets above the level of TCP/IP, where it'll say, this is a packet of encrypted data. It has 16,384 bytes. And so what our SSL stack does is it, reads all of those bytes before decrypting any one of them. But those come in, say, 1,500 bytes at a time, because that's the size of an Ethernet packet. And so basically, I'm trying to kind of fix the way that MP3 expects to read the data, and I'm going to move it from checking does the socket have bytes available to read to actually using a non-blocking read, which is a similar way to accomplish the same goal. But I guess what I'm most interested in explaining to the audience is SSL is this whole thing, and I'm kind of nibbling around the edges of understanding it to solve a problem.
But you said you did have a demo, a hacked demo.
Yeah. So I've got a hack demo. It would play the same stream as I played last week, but over a secure connection, and it does work. So now I just have to turn the hack into something that we can pull request. And the other thing that I will be doing is seeing, so like there's the concept of the async IO HTTP web server. I think a community member contributed this, and I'll also be taking a look at whether that works now that a socket can be pulled or selected, a secure socket, or whether it will still have limitations because of this SSL level grouping of data that's different than packets. So that will be interesting to find out, but that's what is going on here tonight.
Okay.
Right, a fully functional streaming music player with HTTPS soon.
Yep, secure sockets.
Cool.
It's going to work soon.
On a microcontroller.
Definitely time to revisit JetPlayer. The JetPlayer.
Yeah,
2.
There is an open pull request, but it doesn't quite have the latest code, and it doesn't have the hacky script, but you can go on GitHub and check the status of that, or subscribe if you're into it. And probably you'll hear more about the status of that in our Monday CircuitPython public meeting.
Yeah, this is all
True that.
moving towards the like Photoshop and renderings you see of a physical Winamp player, like 3D printing it and a screen, and
Oh yeah, I'd love to see what Rui's brothers would do when we tell them make an MP3 player for us.
All right, thanks so much, Jepler.
Yeah, have a good evening.
Next up, Brent. What you got going on, Brent?
Wouldn't it be great to make an IoT project for Raspberry Pi? Yeah. It would be like, really good. But like every guide is like use Docker Compose, use Node.RED, Mariota, like DB, Grafana. Everything is really difficult. You need your own like database to house all the data, and it's really, really difficult. That it makes the easy projects hard.
Brent, solve this for us.
Where is the thing that makes it easier? So like we could use CircuitPython. We could run Python on Raspberry Pi and send data straight to Adafruit.io, which is our cloud service for IoT. But what if you don't know how to program, or what if you really need to get something going fast? So we have the service set up now called Whippersnapper, and it runs on boards like the Pico W and like the Funhouse, but it doesn't run on things like your desktop, and it doesn't run on Raspberry Pi yet. So that's what we're working on right now, the Adafruit.io team. So we have this really nice interface for selecting components and sensors, and we support a lot of sensors now. And now it actually has to load. But I started a few months ago on the Python library, and like 2 years ago, we couldn't get Raspberry Pis. It was really difficult, and now we can. So I'll show what I'm working on. It's really early. It's not out yet. This isn't our public offering like the Raspberry Pi Foundation has this week, but this will eventually be a public offering. So this is like kind of crazy, but like it will show kind of what I'm doing. So we have like the Raspberry Pi 4, which is like sitting on my desk over here, and it's connected to like one of our Pi cobblers. And then This Pi 4 is over here. It's running Whippersnapper Python. It's also running this tool that we use internally in Adafruit called Proto-MQ. It's an open source tool. It lets us simulate clicking buttons and sending data to and from the device. And it lets me as an embedded developer work with the backend for Adafruit.io without requiring Lauren, one of our web developers on the team, to build things out for me. So this is what it looks like. It's really like hard to understand, but once you start like understanding it, it's not too bad. So Whippersnapper Python, you hit enter, it runs. Then over here is like the data. So it shows that a device is checking in. It's a Raspberry Pi 4B. And on the screen on the left, it shows like digital I/O controller, analog I/O control, this logging is set up. So we have an LED on the Pi connected to pin 5. Focus, but so we'll add a message, digital I/O add an output, telling it to output to D5, and we'll send a positive value. And then we'll hit publish, and the LED turns on. Yay! But also, I have these pins tied together. So if we wanted to read the value of that pin, we would do an input and tie it to pin D6, and this is an event. This is easier on Adafruit.io. We'll actually have like all of what I'm doing manually becomes a form, but this is the really early steps to before this actually happens.
This is like the tooling part where you're building the airplane.
Yeah. And then like part of the tooling is it shows this protobuf payload, and that's how these devices communicate. It's actually a very powerful tool that Lauren's built. And then when you hit publish, it'll send the message to the device that it's going to watch this pin for changes. And then we could write to pin D5, which is our output. And it's a Boolean. We create a Boolean and send it a value of false. And then the LED turns off. And also it shows that it went from true to false. So this is like short demo showing the functionality. I2C works, NeoPixels work. I was testing that. Really excited to get this out to people and start like packaging it together. It's coming together really well.
I know you've been working on it for months, and it's slowly coming alive. It's very exciting to see.
Mm-hmm.
Yeah, what's neat is like within a few minutes you can see if everything's working. Like that's kind of the hardest part.
Yeah.
It's like what do you need to download, do, compile, code, and then 2 weeks later you get like a light to light up over the internet. So
yeah, I assume like we'll have people like run and download and install Whippersnapper on their Pi, but like even with how it's working, like I was using Chrome on my computer, like that's a totally separate computer accessing the device.
yeah.
So like if you're an educator or someone, you'll be able to
Do that for classrooms.
access any classroom Pi and manage them.
That's
which
cool.
will be really interesting.
All right. Well,
nice.
Excellent work. Thanks, Brent.
Thanks, Brent.
All right, Nelly, what you got going on this week?
Hey, folks. This week wanted to release this project. Whoa, there's Adabot. This is a remake of our 2018 soundbox project. It's got that really big arcade button. You press the button, and it plays a sound. So we thought it'd be cool to kind of make it like an educational kind of toy. So we got the NeoPixel LED strip embedded inside the button, and we're using the prop MakerFeather. We've been using this on all of our new props, but it's more of like an educational toy, we think. And because it has the built-in accelerometer, we can shake it. And we can play like a rainbow animation and play different sounds. Excellent. And what's kind of cool is it's all done in CircuitPython. And what you can do is in the audio files, you can name them different color, and that color will change the NeoPixel depending on whatever color you pick. So we have a few of them. We have like I think 9 of them. White. And it randomly plays one. So it's kind of like just a random fun sound box.
Okay.
Red. And of course, we'll shake it again. And it's running off of the AA batteries inside there. It's got a nice snap fit case, and it's got handles so the kiddos can hold on to it if they want. And yeah, it's all CircuitPython, so folks can change out the code. They can add their own sound effects. They want to record their own voices or make it do something else. I saw someone in the comments of the YouTube video was suggesting that it'd be a good 8-ball kind of thing. So you'd shake it, ask it a question, and you'd be like, yes, no, certainly.
Yep.
Yeah, I think it's just like general purpose, prop, sound effect button. I mean, this is a very common thing in a lot of like sci-fi shows, that there's like a robot or like a tool that like you touch or press something and it makes a sound. So I thought it'd be a good basis for bigger projects.
Yeah, totally. And with the Prop Maker Feather, it just made everything a lot easier. It used to use a separate amplifier, separate accelerometer. You had to wire up the NeoPixels.
Also, the audio sounds a lot better. It's like an I2S amp.
Yeah.
It's digital. Sounds good. You can do volume control.
Yeah, if you want to do it, yeah, you can do that too. You can add a stem QT rotary encoder if you want. Yeah, it's just kind of a simple, fun project. The Learn Guide is out now. If folks want to check it out and pick a color.
Nice.
All right, cool. Well, we'll be playing this video tonight along with a speed up on Ask an Engineer, and also people can tune in on Wednesdays for 3D Hangouts, where they can learn how to make all this stuff and more.
Yeah, we just did episode 444, so we're on to 500 at some point.
Alrighty, okay. Thanks so much, Noe.
Hey, thank you.
Thanks, folks.
All right, that's our show for tonight. Thank you so much for joining us, making this the best 26 minutes of our week this week. We'll see everybody on Ask an Engineer in just a few minutes. And don't forget, next week, Wednesday, show and tell, as usual, 7:30 p.m. Eastern Time. Come on by, show and share your projects. We'll see everybody next week.